Welcome to Unit 9 Redox. Today is Lecture A, where we're going to talk about oxidation numbers and what redox is. Oxidation numbers are essentially charges. So when we talked about making compounds in the first place and we used our periodic table, we said that there were selected oxidation states listed on our periodic table. That is basically the same thing as a charge. They're going to call it a full charge if you're talking about an ion, and if you're talking about something in a covalent compound, then they're going to refer to it as its oxidation number, because the electron isn't actually transferred to make a full ion, but they're shared, and it's a measure of who's going to have the electrons most often. So it's a parent charge because of the way they share electrons, considered oxidation state. We have a set of rules. If you learn the rules, you'll be all set with this. The first one is the most important one, and it's probably the one that you're going to forget. Free elements have a charge of 0. And I've been saying that atoms are 0 and compounds are 0 all year long. It becomes really, really important in this unit. If you have one capital letter and they don't write a charge next to it, its charge is 0. It has an oxidation number of 0. That's the one that people will mess up most often. Monatomic ions, mono meaning one, so monatomic ions only have one atom in there. Those are going to have an oxidation number. That's their charge. So for example, if I have a sodium ion instead of a sodium atom, so that's a sodium atom up here. If I take the sodium ion instead, that's sodium when he has a charge. So his oxidation number would be +1. Group 1 are always +1, Group 2 are always +2. This is an important rule because it has no exceptions. Other rules will have a few exceptions. Oxygen, generally -2. If it is a peroxide, if you see that in front, that's a polyatomic ion. So if we take a look at Table E, second column, peroxide, we have 2 oxygens with an overall charge of -2. That means each oxygen has a charge of -1. So in hydrogen peroxide, the oxygens have an oxidation state of -1. Fluorine compounds with oxygen, it can make 2 of them, either OF or OF2. Fluorine has no exception. He is always -1. No exceptions for fluorine, always -1. So if you use your forming naming skills from the stock system, when we had metals that had more than one positive charge, if this one fluorine is -1, this one oxygen must be +1. If this fluorine is -1 and there are 2 of them, that gives me a total negative charge of -2. So this oxygen must have a charge of +2. And it's that same stock system scale. Hydrogen most often is +1. There are a few exceptions if they're with a group 1 or 2 metal. We just said group 1 or 2 metals have no exceptions. So if we have lithium hydride, the IDE, of course, means that the hydrogen is negative. If the lithium is +1 because there are no exceptions, that means the hydrogen must be -1. If the calcium is +2 because there are no exceptions, there are 2 hydrogens. Each hydrogen is -1. Notice that we're looking at the charge of the ion or the apparent oxidation state of one atom and not the overall charge. I'm looking for the oxidation state, not the total charge. When you have a polyatomic ion, the sum of all of the oxidation states in your polyatomic ion will equal the charge of the ion. So if they want to know what the oxidation number for manganese is in permanganate, your first step is to find out what permanganate is. So reference Table E, we find permanganate, and then O4 -1, and we look at the parts. There's 1 manganese, and there are 4 oxygens. My overall charge has to be -1. I don't know the charge for manganese. You can look on your periodic table, but manganese here in the middle has a bunch of different choices, and these are just selected oxidation states, so it's not every single possible one. Oxygen, we know, unless he's in a peroxide or fluorine, is -2. So I have 1 at X and 4 at -2, that's -8. What plus -8 gives me -1 plus 7, so +7 would be my answer. You can do the same thing for a total compound. They want to know what the oxidation number of iodine is in potassium iodate. So KiO4. There's 1 potassium. He's in group 1. He must be +1. There is 1 iodine. Iodine, if we look on the periodic table down here in group 17, has a number of choices. We don't know what he is yet, so we're going to leave him as our X. Oxygen, this again is not a peroxide or with fluorine, so he must be -2. That means I have +1, X, and -8. And remember, it's a neutral compound, so overall it has to be 0. That means my X must be +7. Multiple choice questions that will throw people off. What is the oxidation number of chlorine 0 in which of these species? Here I have a chlorine ion. Notice they tell you the charge is negative. That means -1, so it's not that. Sodium chloride, sodium's in group 1, he must be +1. If this is a neutral compound, that's -1. Carbon tetrachloride, carbon has a number of choices. When he's positive, it's going to be either +2 or +4. I don't know yet. Chlorine also has a number of choices, but since he's second in that compound, he must be negative, which makes him -1. When the halogens are negative, they're -1. There's 4 of them, so that means this carbon must be +4. And here I have chlorine all by himself, 1 capital letter, no charge written in there. He must be 0. That's your answer. Charge and oxidation number are technically different, but in the way that we're going to use them, kind of interchangeable. We're going to apply our skills at deciding what the oxidation number is to equations to explain what redox is. So redox, when we talk about this unit, is reduction, oxidation. So in reduction, what we are looking at is the oxidation number. The oxidation number is what is going to be reduced or oxidized. So reduction means to go down. We're going to show a decrease in the oxidation number. So if I go from pure oxygen, where the oxidation number is 0, to an oxygen ion, where the oxidation number is -2, that number has gone down. That is reduction. How do we go from 0 to -2? We gain negative electrons. Remember that electrons are negative, so if I'm adding a negative number, it's going to be reduced. Oxidation is the opposite. We're going to increase the oxidation number. So if we have hydrogen and he becomes +1 ions, we have increased the oxidation number. He has been oxidized. How do you go from 0 to +1? You have to lose negative electrons. Remember, if we're subtracting negative electrons, the number is going to go up because electrons are negative. The particle that does the reduction is called the oxidizing agent, because in order to be reduced, you have to gain electrons from somewhere, and law of conservation says they have to come from some other species because this is not magic. So what is being reduced is called the oxidizing agent. It causes oxidation. What's being oxidized is called the reducing agent because the same thing, he can't just make his electrons disappear. It's science, not magic. So law of conservation says they go somewhere. They go to whatever is being reduced. So whatever is being oxidized causes something else to be reduced. He is the reducing agent. So you're going to memorize that what is reduced is the oxidizing agent, and what is oxidized is the reducing agent. We can't have one without the other. That's why we call it redox, reduction oxidation, or redox for short. You have to have both because the electrons will need to be accounted for in this unit. One of the mnemonics that I learned to memorize this is oxidation is loss, reduction is gain. So we have oil rig. Another way is Leo goes ger. A loss of electrons is oxidation, a gain of electrons is reduction. They happen together. We can't have one without the other. To figure out what's being reduced and what's being oxidized, we assign oxidation numbers. So the easiest way to show you this is with a couple of examples. If we have the reaction lead plus silver ions, notice there's a plus here, gives us lead ions plus pure silver. They want to know what's happening to the lead plus 1, or the silver plus 1. So this silver is plus 1. I'm going to rewrite it. It's right there. And it's turning into silver 0. His number is going from plus 1 to 0. Notice you just follow the same direction as the arrow in the equation. So anything that has the opposite happening or the wrong number, we're going to ignore. Notice it's not the total charge, it is the oxidation number. So it's one of these two. Then we ask, is that number going up or down? From plus 1 to 0, the number is going down. So that means it's being reduced, and we have reduction. Next example gives us this equation. They want to know what's happening to the copper. So we're going to look at the oxidation numbers of just the copper. Copper is 0 on the left because it's a pure element. On the right, it's in this compound, copper nitrate. You need to know what nitrate's charge is. So table E, we get that out and we find nitrate right here. Has a charge of -1. If each of these nitrates are -1 and there are 2 of them, then this copper must have a charge of +2. So my copper is going from 0 to +2. His number is going up. So anything that says his oxidation number decreases will be wrong, and we can get rid of it. If the number is going up, he must be losing electrons. Oxidation is a loss. If the number goes up, he's being oxidized. So it undergoes not reduction, but oxidation, and that leaves us with choice number 4. The number goes down, it's reduction. Number goes up, it's oxidation. Oxidation is a loss. Reduction is a gain. Oil rig, the oxidizing agent is being reduced. The reducing agent is being oxidized. Please memorize those things. It will make this unit much easier. And that's it for Lecture A.